for our last problem, we'll do question 2 from the 2016 exam. I thought this was a nice one to go over. So the question asks, for t greater than or equal to 0, particle moves along the x-axis. The velocity of the particle is given by this function. And then the particle is at position x equals 2 at time t equals 4. So at time t equals 4, it asks us, is the particle speeding up or slowing down? And so what we'll want to do here is get the velocity and the acceleration at t equals 4. That'll tell us exactly what we need to know. Now remember, it's not just enough to get the acceleration here, because if you had, for example, a negative acceleration and a negative velocity, technically the object is speeding up in the negative direction, right? So you need both the acceleration and the velocity, and then basically to compare their signs. So we're going to have to calculate v of 4 for the velocity at 4. I'll write it down right here. We need to calculate v of 4, and we need to calculate v prime of 4, right, which would be the acceleration at t equals 4. So we're going to go ahead and use our calculator for this. So the function is 1 plus 2 sine of t squared over 2. And to solve it at x equals 4, we'll go ahead and actually declare that function with f of x, and then just have f of 4 to get velocity of 2.978. And then to take the derivative, we could actually do d by dx of f of x, and then denote that we want to solve that at 4. And you can see it even gives us a slope, which is nice. And so it's going to be a positive velocity and negative acceleration, so we know that that means it's slowing down. And obviously we want to write that down, right? So 2.98 for velocity. And for acceleration, it's negative 1.16. So it's going to be slowing down. I'll write the whole thing, save you guys time. All right, now in the next part it says, find all the times t where the interval, t is between 0 to 3, where the particle changes direction. Right, so a change in direction will just be defined as the velocity going from negative to positive, or from positive to negative. And it's just on an interval of 0 to 3, so we can go back to our calculator and we can check out our function, right? This is our function again, and on the interval we see, on the interval from 0 to 3, 3 being right around, well, right around here actually. The only 0 we have is right here, so it only changes direction once at t equals 2.7. And again, just to review, this is the graph of velocity that they're giving us, right? And the velocity going from positive to negative, right? So at one point it was going in the positive direction, the next point is going in the negative direction. So you know that's one change of a direction. Part C asks us to find the position of the particle at time t equals 0. So to do this, we're going to have to take basically the only information they give us for some sort of starting direction, which is at x equals, the particles at x equals 2 during time equals t equals 4. And then we're going to have to basically use an integral on the velocity to subtract distance away from that to see where we are at time t equals 0. So that's going to be the position at time t equals 4, which is going to be 2, plus the integral, right? And we're taking a negative integral, right? So it's going to be from 4 to 0, right? We're going from the velocity 0 to the velocity being 4 to the velocity being 0 of v of t, which will give us the distance traveled over that interval. And so we have to take the integral from 4 to 0 of the velocity. We can go down here, integral f of x, 0 and 4. And that's going to give us negative 5.815. which is 2 plus 5.815, which is going to give us negative, oh, sorry, that's actually supposed to be a negative. Negative over there. 5.815, which will give us negative 3.815. And now the last part asks us to find the total distance that the particle travels from time t equals 0 to t equals 3. This is a very easy one to lose some points on, because if you just took the integral, well, let's actually look at the graph, right? And let's go ahead and take the integral on the graph. And this is, again, I always say that it's nice to have a graphing calculator in front of you because it's really good to get a graphical representation. Let's take the integral from 0 to 3, right? So 0 to 3, and then let's get rid of these two out of our way. So this is giving us basically, this numerical answer is giving us the position, right? Which is what the integral of the velocity is. But to get the total distance traveled, we'd actually have to add this part here instead of subtracting it because it is technically distance traveled. And so the way to do that would be to either break the integral up into two parts and then add this one to this, or you can actually just take the integral of the absolute value. And so you can type in ABS for absolute value and it'll automatically wrap it. And that gives us 5.301, which is going to be the distance. So really easy to lose some points over there. And I would say in general, whenever you have any of those physics terms where your teacher kind of explicitly teaches you the difference, like, oh, speed versus velocity, position versus distance, it's really important to pay attention on any AP test when they're using that terminology, and to be very explicit with what you write as the answer. I guess we should write it out here. Integral from 0 to 3 v of t absolute value dt equals. All right, guys, and that wraps up our AP Calculus AB practice test for 2020. If you have any questions, as always, please feel free to leave it below in the comments. And again, I am new to this, so if you have any feedback or any way I can help you guys succeed on the AP test this year, please let me know. And I will leave links to ClassCalc as well as the practice test in the description below. Until next time.